You to choose a variable to eliminate. Remember I said last time it would be best if you chose not to eliminate z right off the bat. So we could do y, the y variable from the top two equations. Is that what you're thinking? Okay, so one of them's got to be multiplied by -1. Let's multiply the top one by -1. So the top equation becomes -x minus 2y plus 2z is equal to -1. Middle equation remains the same. What are the special cases, by the way? What did we talk about last time? Infinitely many or no solution. Let's try to figure out which one happens here. So if the y variables cancel and you add the x's, you get x plus z is equal to 5. Now we've got to do the same thing to two other equations to try to eliminate y. Yeah, we could. We could take the top equation and the bottom equation, multiply it. You say that one more time, multiply the top equation. That would work, yep. Multiply the top equation by -2, you get -2x minus 4y plus 4z equals -2. Bottom equation is the same, 3x plus 4y minus 3z equals 5, and you might already see what's going to happen here.
I see it.
Do you see it?
Yeah.
Y's cancel, but you end up with the equation x plus z is equal to 3. We already have an equation where x plus z equals 5. Now we have another equation where x plus z equals 3. Is that even possible?
No.
What you would normally do at this point, if we didn't have in mind that this was going to be a special case, what would you normally do at this point? No, if we weren't quite sure what cases, wouldn't you take this equation and try to eliminate another variable? Let's try that. So we have x plus z equals 5. Here we have x plus z equals 3. Normally you would try to eliminate one of the variables now. And at this second step, you could eliminate z if you wanted from now. I can multiply the bottom one by -1. But what happens here is both variables are gone. You end up with the statement 0 equals 2. It's not a true statement. So you say there's no solution. And this is a similar kind of statement that you'd end up with two variables. When you were solving systems with two variables, you ended up with something where 0 equals a number. That was also no solution. Let's take a look at example 3. Solve x minus y plus 5z is equal to -2. 2x plus y plus 4z equals 2. 2x plus 4y minus 2z. Yeah, from these, from the top two, it looks like the y's would cancel just right off the bat without having to multiply anything. So let's choose the top two. You can hold your breath and get a big drink of water. Let's see, so if y is gone, then we have the equation 3x plus 9z equals 0. Alright, we eliminated y. Got to eliminate y again from two other equations. Top and bottom again. Multiply top one by, let's see, +4. That should work, +4, yeah. That becomes 4x minus 4y plus 20z equals negative 8. Weird. Now, before we go any further, consider the one here that I have in blue and the one here I have in red. Say that, you said, Trent, what did you say? So what does that mean? It means they're the same equation. This one in blue is actually the same equation as this one in red. The one in red is just double. What does that mean, though? It means it's infinitely many solutions. But let's at least prove it how we proved it last time. What did it look like if there were infinitely many solutions once we finished all the way at the end? 0 equals 0. That's what's supposed to happen. Let's just make sure it does. If we have 3x plus 9z equals 0, and we have 6x plus 18z equals 0, we're going to have to multiply the top equation by negative 2. And if we do that, x is gone, z is also gone. So we end up with the equation 0 does equal 0. Since there are no variables to solve for specifically, we don't get a unique solution, but this is still a true statement. So this is the case where there are infinitely many solutions. Now do me a favor real quick. Flip back in your notes to when we did lesson 5.1. Look at the case, I don't remember right now what example it was, but look at the case in 5.1 where we had a 2 equation for 10.1. What did I call it, Bedman? 10.1? But it was chapter 10.1. There was a case in there, 1 or 2 examples where we had infinitely many solutions. We didn't stop there. We call it parameterizing. Look through it real quick in your last lesson. It was example 4. Is that what it was? Example 4b. We're going to have to do the same thing here. We have to parameterize, and it's done in a very specific way when 3 variables are there, x, y, and z. The reason that we parameterize is if there are infinitely many solutions, we have to be able to come up with some of the solutions. If there are infinitely many, then that means we need to tell what some of them are. Infinitely many is different than all real numbers. We can't just say, well, if there's infinitely many, then any number is a solution. Okay? And that's not true. I can't just make up any order triple and say, okay, well, 2, 8, 10. That's got to be a solution. Right? Well, how do we know if it's a solution? If we check this, it wouldn't work. So we can't just say any number we want is a solution. There are infinitely many, but they have to follow a particular pattern. So we have to parameterize. And it's done this specific way only by convention. It doesn't necessarily have to be done this way, but I would like you to do it this way because it's going to be easier for me to grade. According to convention, we set up a parameterize, and we're going to let z equal a parameter t, where t is any real number. So we're going to let z act as an independent variable. It's going to equal t, where t is any real number. But the values of x and y depend on what we choose for z, or t in this case. So to parameterize, this is step 1. You let z equal t, where t is any real number. The next steps are solve for x and for y in terms of t. And this is the reason I've said that it's really important that you not eliminate z as a first step, because if that does happen to be infinitely many solutions, if you've eliminated z from a first step, you can't parameterize by letting z equal t, so it makes it really tough. So we've done step 1. We let z equal t. Step 2 is to solve for x and y in terms of t, but you can't do it at the same time. just like if there was a unique solution, we have to work our way backwards from this step back up through the original equations up to this step. So if we go back to either this equation here or this equation here, it doesn't matter which one we choose. I'm going to choose this one, the one in blue. If 3x plus 9z is equal to 0, but z is equal to t, then that equation becomes 3x plus 9t equals 0. You guys agree? Now we need to solve this for x in terms of t. So how do we solve this for x? I guess there are a couple of ways. Let's subtract 9t. So that's going to give us the equation 3x equals negative 9t. Then we divide by 3. So we have x is equal to negative 3t. We know what z is equal to. Z was equal to t. Now we know what x is equal to. X is equal to negative 3t. What's the only variable we don't know? We don't know the y variable. So we take both of the known values now, that z is equal to t and that x is equal to negative 3t. We go back up to one of the original equations, and again, it doesn't matter which one. Choose one of the original ones you think is going to be the easiest. I'm going to choose the middle one. But we're solving for y, and this one doesn't have y in it. So we wouldn't want to do that one. You could do that one to solve for x. So I'm going to take this middle equation, 2x plus y plus 4z equals 2. 2x plus y plus 4z is equal to 2. What substitutions can we make into this equation? Yep, that z is equal to t and x is equal to negative 3t. So make those substitutions. 2 times negative 3t plus y plus 4 times t is equal to 2. That gives you negative 6t plus y plus 4t. Now we just got to get y by itself. We need to know what y equals in terms of t. Everything has to be in terms of t. Z is equal to t, x is equal to negative 3t, but what is y equal to? Y is equal to 2t plus 2. So list what we know. Do we know what x equals? Do we know what y equals? Do we know what z equals? Oh, there they go again. They love that song. Do you want to close the door, Braxton? It's the quadratic formula song. X equals negative 3t, y equals 2t plus, plus 2, and z is equal to t. We have to put this in the form of an ordered triple now. The solution is, instead of x comma y comma z, the solution is negative 3t, comma, 2t plus 2, comma, t. Now why do this? Why is it necessary to parameterize? Using this as a model, we could make an infinite list of ordered triples that would satisfy each equation, simply by letting t equal any number we wanted. For example, somebody yell out a number for t.
7.
7. All right. If t is equal to 7, what are the rest of the numbers? Negative 21 and 16. That would be an ordered triple that would satisfy all three of the equations. Okay? Is that the only one that would work? How many are there that would work? Infinitely many. All you do is just start choosing random numbers for t. 0, for example. If t equals 0, then 2 is equal to y. 0 is equal to x. That's another ordered triple that would satisfy all three equations. Yeah? You always let z equal t every time. That's how you start. Always let z equal t. Okay? That's why we parameterize. Using this parameter t, we can generate any number of solutions we wanted. If there are infinitely many, this is a way we can list any number of solutions that would work. Do you understand the difference, though, between infinitely many and just being all real numbers? T can be any real number, but x and y depend on what you've chosen for z. Okay? Let's do another one of those. I want you to try this one on your own, see how far you can get. This is going to have infinitely many solutions, so I really just want you to practice parameterizing. Getting out of control. Yes, just one sec. Write this down before you go. All right, here we go. Part B, same example. X plus y minus z equals 0. X plus 2y There's one. Can you hear that one boy that's not very musically talented? It's like the primary programs where there's this one obnoxious kid that's louder than everybody. Yeah.
Yeah. I used to sit next to her and she was so tone deaf and I was like, stop!
Huh.
I didn't say it though, she was special.
I'm done. These problems are generally worth 5 or 6 points on a test. Just stopping here gives you 2 points out of the 6. So to get full points on a problem like this on a test, you have to go through the parameterizing process. So, what do we start with? Z equal T?
Do we have to write that down? Or
Write what down?
like, do we have to write that statement on our paper?
No, but it has to be somewhere on your answer that Z is equal to T when you're finished. Yeah.
So after you get 0 equals 0, if you after that you go straight to the z equals z part.
Yep. If Z is equal to T, now you go up one step to either the equation here in blue or the equation here in red, either one of those. If we already know that Z is equal to T, we can solve for Y. So I'm going to take this one in red. If Y minus 2Z is equal to negative 3, we can make the substitution for T. Y minus 2T is equal to negative 3, which means the Y is equal to positive 2T minus 3. Now we know Z is equal to T, and we know Y is equal to 2T minus 3. So go back up to one of the original equations now. We're trying to find X. I'm going to choose the top one. X plus Y minus Z. Make your substitutions. If Y is 2T minus 3 and Z is T, this becomes X plus 2T minus 3 minus T is equal to 0. X is negative T plus 3. So those are all 3 of your variables. Make sure you represent it, though, in the form of an ordered triple. 3 minus T, 2T minus 3, and T.
Could you also express something in Z instead of T?
Needs to be, I suppose you could, but the convention is to set up a parameter T. Okay? So I would like you to follow the convention of our textbook, and that's how I'm going to be grading it. Okay? Any questions on parameterizing?
My mom told me once in very good convention. So.
No, let's just plan on letting Z equal T. Plan on that happening. Okay, last example from this chapter 10.2, then we got to move on to 10.3.
So, assembly grade, what's that about?
Stuff to jar night. Get ready to write. You are going to have a problem similar to this one on your exam coming up. These problems always seem easier when I'm doing it for you, so you might think, well, this seemed pretty easy, so I'm not going to do my homework. I'm not going to practice. That'd be a big mistake. These problems take practice. Okay? Jason receives his rich grandma dies apparently or something, but he gets an inheritance of $50,000.
And that says in the B variant.
His financial advisor suggests he invests in 3 different mutual funds. He needs to have a diversified portfolio, I guess.
Oh my goodness.
A money market fund. A blue chip stock fund.
Can I have 2 minutes to attendance for checkout, please?
Yeah. And a high-tech stock fund. Why would somebody want to invest in 3 different funds? Why not put them all in one basket?
Because that's the other thing
One
that
drops and the other 2 can.
Exactly. The market fluctuates. Different funds do better than some at different times. Some of them have higher risk, but could also have higher returns. Like this high-tech stock fund is probably a higher risk because these startup companies do really well at the beginning and sometimes fail, but if you happen to choose one that does really well, you can make a lot of money.
if it turns out like Apple, then it would
Yeah.
be good.
So anyway, the advisor estimates the money market will yield 5% over the next year. The blue chip 9%. And the high tech 15%. Actually 16, let's do 16. Which is a pretty big return. Jason wants a $4,000 first year return. To avoid too much risk, Jason invests 3 times as much in the money market as in the high-tech fund. Why would he do that?
More secure.
It's which one's more secure?
Money market.
The money market. It has less of a return, 5%, but that's because it's a little more stable. The high-tech one has a higher return, but also higher risk. How much? So the question here's the question: how much should Jason invest in each fund? Because what's his goal? 4,000. So he can't just invest, let's do 20,000 here, 10,000 here. He has to invest it in a way, according to the estimated rate of return, he has to invest it in the exact right amount to achieve his goal of $4,000 return in the first year. So it's not just a matter of, that's assuming the interest rates are what they are, but it's not just a matter of chance. You'll throw your money in there. You got to be smart about it. So, solving a story problem is usually the same type of process. Even though every story problem is different, you still start the same way. You have to know what it is they're asking for. You have to figure out what it is you don't know. If you don't know something, usually what do? If it's a story problem, you make it a variable.
Each test is a variable.
So each one is an equation.
Money market, which is probably
So you're saying, now we've got to be a little more specific on how we decide. If I say let X equal money market fund, that's not real specific. What about the money market fund? What color it is, when it started, how much he will invest in them. You got to be really specific about how you label these variables. So is that how we're going to label variables? Should we let one variable? Now here's the problem sometimes with if you assign 20 different variables, that's okay, but how many equations do you have to have if you have 20 different variables? You got to have 20 equations. You have to have the same number of equations as variables. So if we are going to have x, y, and z as variables, how many equations do we have to come up with from all of that? 3, which is challenging. So you always need to be careful when you throw out variables. You have to make sure that you're going to be able to come up with the same number of equations as variables. We may be able to.
well, there might be a way to make it easier. You could simplify it down to 2 variables. If the money market variable is instead 3, whatever the high-tech fund variable is, let's say it's 3 times the amount.
Yeah, we might be able to do that. Let's just assume, though, that we're going to have 3 variables. Let's let x equal the amount invested into money market. So corresponding, we can let y equal the amount invested into blue chip fund. And let z equal the amount invested into high tech. That's the easy part, assigning variables. That's not necessarily difficult to do. It's coming up with the equations. It would help you much more if you came up with these rather than copy down what I've come up with. So, what do you think?
You do x plus y plus z will equal 50,000.
Okay, let's talk about it. We had a suggestion here, x plus y plus z equals 50,000. X plus y plus z, isn't that the total amount of money that he has to invest? And how much money does he have to invest? 50,000. So does that sound all right to you guys? All right, there's one equation. 1 down, 2 to go. X plus y plus z equals 50,000. Let's talk about that one. Whose suggestion was that? 3x minus z. What information are you getting that from?
He invested 3 times as much money in money market as in the high-tech fund.
Okay, I'm glad you went there because this kind of a statement is always confusing. Where is that? Jason, to avoid here it is. Jason invests 3 times as much in the money market as in the high-tech fund.
Oh, don't you just do 3x on the end of the z? Just plain z. But then you have to let that has to be 3z. Okay, yeah.
Okay, this is where students get confused. Is it 3z equals x or is it 3x equals z? Because those are 2 different things. So let me write it this way. Here we have z and here we have x, right? Is he going to invest the same in both? Does z equal x? No. Ultimately, where is he going to put more money?
He's got to put more money into x. So doesn't x have a larger value than z already? So if you put another 3 right here and multiply, you've made it even larger than z. But we want these to equal each other. So you don't want to put the 3 by the x because x is already larger than z. Where do you want to put the 3? You want to put it over here because now they equal each other. Because x was 3 times as large to begin with. So you multiply 3 by z. Now you've got an equal an equation there. Does that make sense? It's very hard when you try to think about that literally. 3 times as much into x, and you think, okay, well that's 3x. But that means x is already 3 times as large as z. So in order to equate the two variables, you have to times z by 3.
So there is a second equation. 3z is equal to x. 3z is equal to x. Yeah.
Wouldn't this be a slightly easier to solve considering that there is one pair of 3 to 1 in 50,000 with extra which is 30,000? That would be 30,000 in money market, 10,000 in blue chip, and 10,000 in high tech. Money market is 3 times that in high tech, and all the money is invested.
That's one possibility that could work. Does it satisfy all 3 of them? It satisfies the first 2, but there's one more piece of information that we're not sure it satisfies. How much does he want as the return in the first year? So you have a good point there, Kyle, but does that make sense? We got to make sure it satisfies this last piece of information that he wants $4,000 return. How do we write an equation? This one is probably the most difficult. A money market, where is it? Right here. Money market yields 5%, the blue chip is 9%, and the high tech is 16%.
Can you do 0.05 times 0.05x plus 4%, like 0.095 plus
We start over 0.05x.
So do like the percentages for them and then equal it to 1,000.
Okay, so 0.05x, this is 5% of whatever he turns in for the money market. Is that what you're talking about?
Yeah.
So then plus 0.09 for whatever he turns in for the blue chip, plus 16% for whatever he turns in for the high-tech fund. And that's supposed to give him a return of 4,000. What do you guys think about that? How many different equations do we have? 3. How many variables do we have? 3. If you have 3 variables, you have to have 3 equations. And they have to have 3 different equations. We have 3 different equations here. We may be able to solve this.
So but if that was like the equation, would that be like?
Yeah, that can work. Now, decimals might make this a little harder. Do we want necessarily to keep the decimals, or we want to get rid of the decimals? If it were me, I'd get rid of them. How do we get rid of them, though? Let's multiply it by 100. It would be better to get rid of these decimals. So that becomes 5x plus 9y plus 16z. Oh boy. That's going to be 400,000. Why did I put a 50 there? It's 50,000. X plus y plus z is not 50. It's 50,000. So we still have to solve. We've got our 3 equations. Here's equation 1. Here's equation 2. Here's equation 3. How are we going to solve these? Check this out, you guys. If you consider equation 2 right here, which variable is already gone from equation 2? Y is already gone. So why not take equation 1 and equation 3 and eliminate y and combine it with equation 2? Does that make sense? So let's take equation 1 and equation 3 and try to eliminate the y variable. In order to do that, but that would get rid of x. We want to try to get rid of y, because y is already gone from equation 2. So we got to multiply the top equation by -9. So this becomes negative 9x minus 9y minus 9z. Uh-oh. 50,000 times negative 9 with no calculator. Negative 4. I think somebody said it the right way, but very.
150,000.
400,000. It's 400. It's negative 450,000.
Yeah, honors you did.
If we eliminate y, we had negative 4x plus 7z equals negative 50,000. We already had an equation here, equation 2, that where y was eliminated, but we have to write this a little bit differently. X minus 3z is equal to 0. Now what? We've got these two equations both in terms of x and z, so we can eliminate one more variable, or we need to eliminate one more variable. Multiply by 1 by 4, that ought to work. So we're going to have the equation negative 4x plus 7z negative 50,000. Yep. 4x minus 12z equals 0. X is gone. We have negative 5z equals negative 50,000. Ooh, this divides nicely.
Yeah, we picked good numbers.
Z is equal to 10,000. So Kyle, your guess was right. Now, if he invests 3 times as much into money market as high tech, because this is the high tech fund, how much is he going to invest in money market? So that's X. X is equal to 30,000. And he only has $50,000 to go around. He's already used 40,000. So Y has to be 10,000. Okay? And just to be exact, you need to go back and state exactly how much goes into each fund. So 30,000 into money market, 10,000 into blue chip, and 10,000 into high tech. Not only does that use his entire investment of $50,000, he's invested it in such a way he's going to match his goal, assuming the interest rates for that year stay stable. He'd match his goal of a $4,000 return. Okay.